said, the application of fractional calculus is very important. Even in the theoretical part, we have a very good improvement, but in our talk, we want to focus on some application of new fractional operators. And the outline of my presentation is as follows. First, I recall some definitions and preliminaries about Caputo, Caputo-Fabrizio, and ABC fractional operators, three well-known singular and non-singular fractional derivatives. Then we present our mathematical model in classical and fractional concept. Then we present a numerical method to solve our model formulation. In this section, we can extend trapezoidal method in fractional sense in three aspects: Caputo, Caputo-Fabrizio, and ABC. We discuss the stability and convergence of our numerical method. In the next section, we present a control idea as an insecticide approach to overcome the disease in our case. In section 5, we present some simulation results. And finally, in section 6, we end our presentation by some concluding remarks. Let us start with definitions. In this section, as I said, we introduce three different fractional operators with singular and non-singular kernels. For the singular operator, we consider Caputo fractional derivative, while for non-singular ones, we take into account Caputo-Fabrizio with an exponential kernel and Atangana-Baliano-Caputo with a Mittag-Leffler kernel. As the first definition, let us consider the definition of Caputo fractional derivative. Given a function x on a time interval 0 and t, we define Caputo fractional derivative and its corresponding fractional integral as in equation 1 and 2. As a properties of this classical definition, we can introduce or we can present the Laplace transform of Caputo derivative as in equation 3. The next definition is related to the Caputo-Fabrizio differential and integral operators as in equation 4 and 5. As can be seen here, the kernel of operator is an exponential function. The Laplace transform of this fractional operator is computed by equation 6. Now we recall the definition of ABC differential and integral operators by equations 7 and 8. As you can see in the definition of ABC fractional derivative, we use a Mittag-Leffler function as its kernel. And the same, here we present the Laplace transform of ABC differential operator as in equation 10. Now let us introduce our model as a dengue fever outbreak in a practical case which happened on the Cape Verde Islands in year 2009. To describe the dengue fever epidemic model, the human population is decomposed into three counterparts as susceptible, infected, and immune individuals. In reference 4, the classic model of dengue fever model has been given by equation 11. In this equation, SH and IH denote respectively the number of susceptible and infected humans, while RH represent their population having acquired the immunity against the infection. In this model, the disease spreads by the bite of female mosquitoes. Here we consider two groups for the female mosquitoes population as susceptible and infected ones. The number of infected female mosquitoes is denoted by IM, while the population of susceptible ones is signified by SM. We have two other parameters here as NH and NM, which are the total number of humans and female mosquitoes respectively, which are constant and computed by NH equal to RH plus SH plus IH, and NM is equal to SM plus IM. The interpretations and the values of the other parameters are given in table 1 according to the reference 5. Note that here we just consider the female mosquitoes, since the male ones do not bite humans, and hence they have no impact on the disease dynamics. In addition, for the female mosquitoes, the only blood source is human. Therefore, we consider the parameter M equal to 0 in our model. Also, the initial conditions for this system are considered as in equation 13. These initial conditions reflect the fact that initially the mosquitoes population was uninfected and traveling unhealthy humans imported the virus into the ecosystem. Why we use fractional model here as a general concept? Although the model 12 describes some basic behaviors of the ecological system under consideration, the others in reference 5 showed that the solution of integer order model 12 does not provide a good match with the real data that we have from our case study. On the other hand, many scientists have shown that the fractional models are in better agreement with the experimental data than their integer order counterparts. Therefore, we followed the concept of fractional calculus in the mathematical modeling, and we will try to modify the dengue fever model by using the new aspects of fractional calculus in order to provide more precise results close to the real data. To do so, we'll replace the integer order derivatives by one of the fractional operators described in section 1. I mean, Caputo, Fabrizio, and ABC. Note that mosquitoes in our model, mosquitoes and humans may not behave in the same way. Therefore, we select two different fractional orders for the equations presenting the dynamics of mosquitoes and humans. Therefore, in addition, some parameters in the system model are modified to ensure that the right and left-hand sides of the resultant fractional equations have the same dimensions. Indeed, we do this modification in order to avoid dimensional mismatching. Finally, we provide the following fractional model for the dengue fever case in our study. As you see, we modify the parameters to have dimensional matching, and also we use fractional operators in the left-hand side. This operator can be Caputo, Fabrizio, and ABC. Finally, in the simulation results, we compare the use of different operators in our case. As can be seen in our model, as QH and QM tends to 1, the fractional system tends to the integer order model as expected. Now we present a numerical method to implement the fractional dengue fever model in our case. Here we modified the trapezoidal method in the Caputo, Fabrizio, and ABC. To do so, we consider the fractional dynamic system as in equation 15, where dq can be Caputo, Fabrizio, or ABC. In our model, x as our variable is the vector of SH, IH, RH, SM, and IM, and x0 denotes the initial condition vector. And also f, according to our model, is a real valued continuous vector function satisfying the Lipschitz condition. As a starting point for our numerical method, first we apply the integral operator to our equation 15. We apply the integral operator to the both sides of equation 15. According to this action, we will find the integral equation 17. Now we consider a uniform mesh on our time interval as t0, t1 until tn, where tau is the time step size. Also, we denote xn as the approximate solution of x at tn. According to the definition, let us continue our trapezoidal method first in the Caputo sense. In this case, applying the integral operator in the Caputo sense, we find the following integral. To continue our method, we approximated the function f as piecewise linear interpolation polynomial according to equation 19. Therefore, inserting the above approximation into equation 18, we obtained equation 20, where the coefficients is defined by equation 21. Consequently, we can provide equation 22 as the fractional trapezoidal method in the Caputo sense. We can follow the same procedure to derive the trapezoidal method in the Caputo-Fabrizio sense. First, we discretize the integral given by equation 5, which provides equation 23, by inserting the approximation of f as a linear interpolation polynomial from equation 19 into equation 23, we can obtain equation 24 as the Caputo-Fabrizio fractional trapezoidal method, or trapezoidal method in the Caputo-Fabrizio sense. In equation 25, in equation 24, the coefficients are computed by equation 25. Following the same procedure, we can provide the fractional trapezoidal method in the ABC sense by equation 26, in which the coefficients are computed by equation 27. Now we present two theorems for the stability and convergence of numerical methods, our numerical methods in the sense of Caputo-Fabrizio and ABC. For all three cases, we can say that the numerical schemes are conditionally stable and conditionally convergent. We proved these two theorems in our paper. Conditionally stable because we have to have some conditions between the parameters. Under these conditions, we can prove that the numerical schemes are both conditionally stable, are both stable and convergent. Let us move to the control idea in our case. In this part, we consider an insecticide campaign to kill the adult mosquitoes. The level of this insecticide is modeled by inserting a new control parameter to our model. Then we try to design a linear state feedback controller to make the disease-free equilibrium point asymptotically stable. To do so, please consider the following fractional control system in which the parameter P in this control model is the state feedback gain constant. Here, our objective is to find a stabilizing control gain P, which ensures the asymptotic stability of the disease-free equilibrium of the closed loop system 28. Please pay attention to this remark. In order to design a stabilizing controller, I mean the parameter P, should be selected in such a way that the following basic reproduction number becomes less than 1. As can be seen, the parameter R0 follows a decreasing manner as the control gain P increases. This fact guarantees the existence of a stabilizing controller satisfying R0 less than 1. Let us share with you our simulation results here. In this section, a comparative study is carried out between the simulated curves of the fractional model 14 and the real data for a dengue fever outbreak that happened on the Cape Verde Islands in year 2009. Our simulation and comparative results are shown in figures 1 to 5. Let us start with figure 1. As can be seen in figure 1, the simulated curve of Caputo derivative with QH equal to 1 and QM equal to 0.77 better approximate the real data than the classical integer model. In this figure, we just compare the best Caputo fractional model with integer order model and real data. It is clear that the fractional model in the Caputo sense works better than the integer order model. In the next figure, we compared the fractional Caputo-Fabrizio model with integer order model versus real data. And here we can see that the best Caputo-Fabrizio model also works better than the integer order model. I mean the best Caputo-Fabrizio, we tested different fractional orders to find the best fractional orders in the sense of Caputo-Fabrizio. In the next figure, we compared the ABC operator, the simulation results of the ABC operator as compared with integer order model versus real data. As can be seen, although the ABC is not perfect, but it works better than the integer order model. Let us put all figures in one figure to find a nice conclusion. I lost my page. Just Professor Nejati, can I share again?
You can. But you can see on the screen.
Can you see my file?
Yes, you can see that.
But small.
Small one.
Yes.
We can see your file, but small size.
But you can increase the size.
You can use the full size.
Yeah. This is small size now.
But I cannot see my file.
What about full screen? You can try that.
Ah, it is full screen. What is this?
No, you can go to the last square, right hand side square near to the cross. Then it will become full screen, I think.
Is it okay now? Is it full screen now?
Not yet.
No, not yet.
Not yet. It's still small.
Yes,
can
that's
I-
good.
Perfect,
That's okay.
perfect.
That's
Good
okay.
now. But
No, I can't.
Just wait.
I have problem here. Sorry. Sorry, I have problem here. Can you see my file now?
Not yet.
Not yet.
Yes,
Perfect,
that's
okay.
okay.
Perfect.
First
Carry on.
page, right?
Carry on. Yes, yes.
You can see the first page, yes?
Yes, yes, that's right.
Let me. Okay. Is it okay now?
Yes, it is okay.
That's
Okay.
good. Okay.
Okay. Let us see all different simulation results in one figure. Integer order case, Caputo-Fabrizio, ABC, and real data. As can be seen in figure 4, the simulation results with Caputo-Fabrizio operator is close to the real data in the earliest stage of the epidemic. Here you can see that in the earliest stage, up to the peak of the number of infected humans, Caputo-Fabrizio works better. However, ABC operator captures the qualitative features of the real data for the later part of the time interval. You can see before the peak, Caputo-Fabrizio works better, but after the peak, ABC is better. Therefore, we can come to the conclusion that a combination of ABC and Caputo fractional models is the best candidate in our case, according to the real experimental observations. In this case, we considered the changing point between two models in the time domain as the intersection of two plots associated with Caputo-Fabrizio and ABC, which was obtained as t equals to 36.4. Therefore, we suggest here the hybrid function or the hybrid model. The final hybrid simulation compared to the experimental measurements is depicted in figure 5, which illustrates surprisingly good results. Here, the result of our hybrid model. Before the peak, we use Caputo-Fabrizio model, and after here, we use before the peak, we use Caputo-Fabrizio, and after the peak, we use ABC. Now we consider this hybrid model as the best candidate to model our case, and we applied the state feedback control strategy provided in the previous section to make the disease-free equilibrium point asymptotically stable. In this case, we selected the state feedback gain constant and P as P equals to 0.5 and 5 respectively for the first and the second part of the hybrid model to satisfy the sufficient stability condition 29. Computational investigations related to the human population with control are displayed in figure 6, which verify the efficiency of the proposed insecticide campaign stabilizing controller. Please note that our control strategy has biological interpretation. It is a kind of insecticide approach. Let us close our presentation by some concluding remarks. In this research, we proposed a new approach for the modeling of dengue fever outbreak by using its new formulation in fractional calculus. I mean, its hybrid model. In our research, the efficiency of this new framework was examined by using a set of real data registered by WHO. The proposed model considered a new hybrid structure involving the fractional operators with the exponential and metaglyphilar kernels. For the purpose of implementation, a new and efficient numerical method was developed by extending the trapezoidal method in fractional sense. Here, we proved the stability and convergence for all three fractional cases. Comparing the numerical experiments with the real data verified that the proposed hybrid fractional framework can describe the reality very well in the whole of the time interval, better than the pre-existent integer and fractional order models. In this study, we also considered an insecticide campaign as a state feedback control strategy. Simulation results showed that the suggested controller has the capability to prevent the outbreak and to reduce the number of infected individuals. Here you can see the references of this work. And finally, I would like to thank you very much for your attention and sorry for the interruption between my presentation.
Thank you, Professor Amin Jajarmi. It's a really nice presentation, and you are giving the so valuable things to understand the numeric analysis, to analyze the simulations of the fractional models. So
Thank
it's
you.
really wonderful, and I learned too many things with your presentation.
Thank you, Professor.
Yeah, I invite to the some remarks from the eminent researchers side, and as well as some questions.
May I ask a question, Praveen? Is it possible?
Yeah, please, Sohail.
First, thank you, Dr. Jajarmi, for your nice presentation and also very nice hybrid approach combination of Kappa-Fabry-Zero and ABC derivative. It was very nice, but I have a question. Your controller was asymptotically stable, but your approach that you have selected and choose was conditionally stable. So how can we combine them? And also later you combine CF and ABC derivative to propose a new approach. Then how can we conclude about the controller was asymptotically stable and the approach is conditionally stable? How can we combine these different stability behavior?
Okay. Thank you, Sohail, for your nice comment. To answer your comment, I can say that these convergence about stability for numerical method and for the system is two different topics. For the numerical method, the stability convergence is one side, which is completely independent to the stability of the system. For the stability of the system, we use, for example, Lyapunov theorem or other aspects of other theorems for the proof of stability. But for the stability of numerical method, we use, we can use, for example, fixed point theorem, or in this, we can prove it by using Cauchy sequence in the Banach space. Therefore, these are two different topics. For the stability of the system, for the asymptotic stability, the trajectory should tend to zero asymptotically. We can prove it by different theory. But for the numerical method, it is unrelated topic. Therefore, for the numerical method, we have conditionally stable, but for the system, we have asymptotically stable. So, these two topics are not related to each other. Two completely different topics in this case.
Okay, thank you.
And you are for your second. What was your second question?
No, this was the first one. A combination of your hybrid method, in fact, also at the same time, controller is asymptotically stable. But are you sure about when you combine Kappa-Fabry-Zero and ABC at the same time, also your approach, numerical approach, is still conditionally stable, and also at the same time, again, your controller be asymptotically stable as well, or no?
To be honest, I haven't checked this important point. Separately, we checked each operator to be conditionally stable in the sense of numerical method and asymptotically stable in the sense of dynamical system. But in the hybrid sense, in the hybrid case, we didn't check what happened. But in the simulation results, we see that both stability in the sense of numerical approach and dynamical system happened.
Thank you, Amin. Very nice. Thank you.
Thank you, Sohail.
Praveen, can I say something?
Please.
Thank you very much, Amin, for your nice presentation. Amin, as Praveen and Sohail and many other colleagues who presented, belonging to the new generation of fractional calculus, very successful young people and very, very good results, very good background. I would like to ask you a question. I am not sure if you saw the book I have presented about the integral operators. There are lots of kernels. Which kernel do you believe, which type of kernels do you believe is appropriate for epidemiology? Which properties the kernel should satisfy in order to be successfully applied to epidemiology models?
According to my experiences, dear Dumitro, it depends on the system under study. I checked several cases in our papers we check together, and we see that for each one operator works better according to the real data. Even with the other set of real data, sometimes we found that the other operator may works better. Therefore, according to my experience, for each set of real data and for each case, we have to check to see which of them works better. I couldn't find an algorithm or a formula to find before checking the simulation results.
Yeah. There is another problem for epidemiological model. I will present a question I have received from a journal, and I have to give an advice I give. The problem is like this. In epidemiology, we can use du over dt equals integral from 0 to t k kernel t minus s us ds, right? Good. Where the fractional calculus model appears here. These kernels, for example, if we squeeze the k, the kernel, for some cases, reduced to d over dt is u of t minus tau, which is delay differential equation. So the person who is very good and famous said, how can we derive the fraction? But this form, if you put it in this form, du over dt classic is integral from 0 to t of k of t minus s u of s ds. You can define the generalized fractional operator integral, we can adapt it, and then we can take the inverse if there exists, and this is clearly derivative model formulated with generalized fractional derivatives, and then fractional calculus appears natural. So this is what I'm talking, what Praveen is trying to generalize, and if you look to Boltzmann, I'm not sure if Jordan is here. If you look to Boltzmann paper from 1874, he proposed a relaxation of this form, general of t minus tau u du ds. So fractional calculus and generalization of fractional calculus appear naturally. The main problem in epidemiology, also Carla said and many others said, is to fit the biological processes, not only the data. For example, tumor is growing, we have oscillations, but in our model, we don't have oscillation because, it's difficult. Fraction is somehow related to friction and destroy the oscillation. So this is the main issue in the mathematical biology in general, to have a biological meaning. We have biological processes on one side, for example, cancer. Cancer is developing, HIV also developing, right? HIV. Viruses, But what can we do with the biological meaning? This is the problem. Mathematical is correct. You said very, very nice. I give you data, I can find the model because it depends on the optimization procedure. And optimization procedure, if it is good, then alpha will never be 1/2, 1/3. Believe me, for nonlinear differential ODE, it will not be like this. So these are genuine. But how about the biological meaning? This is a problem. For example, for viscoelasticity, we have to combine the principle of physics thermodynamics. We are not doing at this moment properly. For example, there is a paper written by Balint and Balint. These guys are from Romania regarding the models where the observability is not fulfilled. But this is not against fractional calculus. Fractional calculus is for complex systems. Don't forget, fractional calculus includes the integer order, like we did in our paper, like you know in our paper. So includes the classical one. It is beyond. So if you are unable to do it classical case, you go to nonlinear higher order models. If not, you put delay, you combine impulsive, you put fuzzy, depending on the problem. There is no clear model of everything doesn't exist. So that's why there are some type of questions that we have to ask for the reviewer. What is the meaning of fractional calculus? Give us a meaning for the model. Only that it described the non-locality is not enough now. We have to give in modeling more details about that model. That, for example, COVID. So this is a problem, or cancer, or other things. But the last question I want to ask, Amin, what do you think about the future of mathematical biology with fractional calculus? Thank you, Amin, for everything.
Thank you, Dimitri, for your clear explanation. First, I would like to say something about mathematical modeling, because there is some discussion between singular or non-singular, fractional, non-fractional. I think for a model, it is important. Some points should be taken into account. One, the model should be correct mathematically. Two, the parameter and the operator, independent of its fractional or non-fractional, the model and the parameter and the operators should have interpretation. If you work in biology, it should have biological interpretation. So first, the model should be correct mathematically. Second, the model should have interpretation in practice. And third, it should cover the real data. If the model has these three conditions, therefore the model is good. Even it is fractional or non-fractional or singular or non-singular, from my viewpoint, it is not important that the model, that what we call the model. It is not important. The important point is that it should be correct, it should have interpretation, and it should cover the real data. And about the future of mathematical modeling in fractional calculus, I mean, we can test different operators like what our friend Agarwal suggested. It is definitely, it is mathematically correct if we can find a good interpretation, and if we can find a good matching real data, then it will be a good model in fractional calculus. It can be a new way of continuing way of mathematical modeling in fractional calculus, from my viewpoint.
Thank you, Professor Amin and Professor Dumitro. And to manage the time part, so I am really thankful to you. Professor Jafari is asking some question, but if organizer allowed to me, then I can permit it. Otherwise, thank you very much because the closing ceremony is going to the close.
Yeah, you can give 1 second. That's okay.
Yeah, Professor Jafari, please.
Thank you so much. Thank you for your presentation, Prof. Jajarmi. It was very interesting. And you solve a system by different type of operator. And it is, as I understood and we expected, the Caputo fractional derivative was better and it matched with your model. But you solve a system and you just show one of those variable. So for other also, you had the same result.
I didn't understand what you mean.
Look,
You're
you solve a system, not a
Yes.
one equation.
No,
But
a system. Yes, a system.
yeah, but in the
We
system,
solve the system in the sense of
Yes.
Caputo, Caputo Fabrizio, and ABC
yes,
separately.
but in the result, you just show one of those function in the system. For example, if your system has a 3 variable, you show one of them.
Yes.
Because maybe that is important. But I
No,
want
no,
to know for
not
other
just
variable.
important, not just important, because we just have real data for this variable. Because we want to compare, we want to find the conclusion according to the comparison between our numerical result and the real data. And in this case, in our presentation, we just present the variable which have its corresponding real data. But in our paper, we show all other variables and figures.
And I just want to know, did you check the errors for those 3 operator? Because
you mean numerical errors, right?
Yeah, because you had a continuous function as a solution,
Yes.
exact solution.
Yes.
Then you find also 3 function, all of them, as I saw in the picture, all of them was continuous. So we can find the interval of the errors. So I want to know if we check the errors. I think as I saw in the figures, the Caputo was better, Caputo operator. And because Dimitri also, he is here also, because one time I asked him also, because I think the Caputo Fabrizio, just the approximation of the Caputo derivative. And then ABC also, it is also approximation of the Caputo derivative. This is my idea, but he was not agree with me. This is my idea. And in this talk, you show the Caputo was better really in the whole interval as I saw. But as a mathematician, one example is not always correct for everything. But I just want to know, did you check the maximum error in the whole interval or not?
Please, Professor.
Yeah, I mean, if you have some quick reply, then please go ahead. Otherwise, we can go to the...
Okay, dear Hussein, we checked the error between each model and real data, and we find out that the hybrid model, as a combination of Caputo Fabrizio and ABC, has less error in comparison with the real data. But in terms of computational error, we didn't check it. Maybe, but the computational errors is related to the numerical method we choose. Maybe by selecting another numerical method, we can find better numerical computational results. But in comparison with real data, our hybrid model works better as a combination of Caputo Fabrizio and ABC. Even better than Caputo Fabrizio, better than classical Caputo.
Thank you so much. Thank you.
Thank you, Professor.
Don't worry, Hussein, don't worry. These non-singular operators have applications. You saw the book I downloaded for you. There is exponential kernel. There are some phenomena described by exponential kernel. So no problem. with Caputo. There is no conflict between Caputo Fabrizio, and Mita Leffler kernel or other type of kernel. Or if you put any kernel in there, there's no much contradiction. There are some relationships between the so-called new operators and old operators. This is another story. But Caputo Fabrizio was imposed from different reasons by Caputo. Not because Caputo because Caputo was extremely largely applied everywhere, and he said it is impossible the power law kernel be successful in all type of phenomena, biological, economical, social sciences. This is impossible. This is clearly impossible. So then he said we have singularities, so let's have some operators which have a physical meaning for some phenomena, which describe better some phenomena. This was the reason. And if you look now to the new Caputo definition from 2021, they improve it, and it is non-singular, and it is applicable now without any initialization problems, because you saw in 2008 in this paper, all problems related to the origin initialization were mentioned clearly. So no need to read from others who rediscover after 10 years. No need to rediscover. It was written clearly in there, page number 3 from the book. Go there, see exactly everything, and then come back to 2018, 2019, and see same. Impossible. We are researchers. I don't want to give names because don't want to be involved in. Yeah.
Yes.
So thank you. I am sorry for this. Thank you, Hossein, for a nice comment, and to Praveen for chairing, and Amin for answering. He was in the best position today to answer many questions from many guys.
Thank you for clarification. Thank you so much.
Thank you once
Thank you,
again, Professor
everyone.
Jumetro, Professor Jafari, and nice talk for the Amin. Thank you very much.
Thank you, Professor Agarwal. I want to announce an update about the program. We would like to do closing ceremony before the parallel sessions. And so I give this information to the participants. Please let me know for closing ceremony. Yes, please, Professor Özdemir.
Okay. First of all, I would like to thanks all the participants and support to their our conferences, and we just slightly change before the closing ceremony. So last 3 days we have much interesting work and much interesting talk, and I also very happy to sharing the nice idea for especially youngest and researchers for international collaboration. This is very important for scientific area. So now we are nearly end, and we are switched to closed section. What we are going to do, and yesterday we had some roundtable and we discussed some topics and about the future of our conferences. Everybody say we have to be carry on. I don't know what you want to say. Are you same idea or you say something else? But more or less, they said we can carry on. Might be we extended some topics as well. Could be 22 and 24 is already reserved. Some other conferences, maybe 23 it is good idea, but we haven't decided yet. But could be 23 is best one as far as I see that. And now what I am going to do, just you can give you some short remark if you want to say anything about the conference and future conference, because of we have another parallel session. Some of the parallel session, one of my colleagues just remarked me, they started, but I hope they will join during this time. We don't have too much time because of the time limited. And we can, what I am going to share with you might be if on the web page there is in a journal name. Let me share. İbrahim Hocam. In here, you can see there is a journal in here. Before to go to this step, I would like to be inform you. We are going to send your email to join the certificate, so you can receive it by email as soon as possible. And we have some special issues for these conferences. This one, first one, International Journal of Optimization and Control, which is in the Scopes journal. And the second one, Journal of Computation and Applied Mathematics, ICAME, is SIC journal, Mathematical Modeling of Natural Phenomena, as you know, is also SCI expanded journal. And Numerical Algebra, Control and Optimization, Index ESCI, you can see that, and Springer, and other fractal and fractional, which is some colleagues have some special issues. So Journal of Vibration and Testing and Dynamical System and Mathematical Modeling in Numerical Simulation with Application. If they want to, they can. In here, we already sent some information about the chair of the parallel session, and we get some knowledge from them. And also, scientific committee will look at that, and it is dependent in the journal aim and scope because of the, as you know, we have to be in 1918. I mean, 2018, so we get in a high quality paper, we already published. There is no problem. Some of them books, some of them the journal, whatever. And in here, the same policy we are going to be follow, but there is not on all of paper will be published. This is impossible. So please send to, I mean, you have to be prepared high quality paper because of this conference main idea. It is main things is scientific qualification. We also publish the books as well. If you want to say anything to, please just you can share it with us.
Ramazan Hocam,
Yes,
please speak.
Okay,
Please
thank you very
speak,
much for
Hocam.
all. Okay, we are going on following you. It's good. Do you want to add anything? Because next conference could be 2023, I guess. It's the right time for the other conferences. It's not overlapping with the others. And the subject is going to be, I guess, yesterday evening you discussed actually models and their validation or their accuracy could be good, I guess. And anything more that? Also, we are going to do conference hybrid form, face-to-face and online could be. And any more? If I forget.
No, no, it's okay, it's okay.
Yeah,
Okay. Mm.
yeah, keep going on,
Okay.
working hard, trying to good things, make good things for all world.
Is
Yeah.
there any question from the all participant, please? Or would you like to say anything, please? It is important for us. Thank you.
Maybe if there is no question, maybe Nejati, we can do some more, give some more details about the roundtable we have discussed.
Yes,
We discussed
yes.
about the conference and also about the operators. So it seems that some of our colleagues try to compromise on the singular and non-singular operators, and finally we reach a certain agreement to continue working on these two directions and to get good results. Let's see what are the results in modeling is the main target. For the conference, the next conference, I think it will be 2023, right?
More or less, yes.
Mainly, yes, mainly. So all participants are invited. Revising and enlarging the topics, which means to invite some plenary speakers, invited speakers. Of course, it is not easy to invite in face-to-face conference, but if you make hybrid, then you can invite from US, for example, in hybrid, and in face-to-face, the ones who like to come. It can be a solution, They are talking about International Conference of Fractional Differentiation and Applications in the same way. It will be in China, 2022. Next week is going to be in Poland, in Warsaw, but in Poland is online, pure. And in China, they try to make it hybrid. Maybe we can think to such kind of hybrid. You don't have to pay any cost for invited speakers in online in the part of hybrid. You concentrate on the cost and on the topics with the people who are willing to come. And, there are 4 invited speakers. That's it. You can do it for 3. You can accommodate. And for the hybrid part, if you like to increase the topics, then you need more invited speakers. This is the idea. Putting a topic means not just putting a topic and waiting. You should bring a leader from the part to speak about open problems and then to make collaboration and so on. So these are the things. Maybe you'll decide with the committee, Ramazan Hoja in your nice committee, Delia and the others, Yabu Socha. What can I say more? So I'm very happy that we are about to find an agreement for the non-singular and singular operators. So this is a good news for the young people. And I would like to congratulate you, Professor Ramazan, Professor Deria, and all local organizing, and would like to congratulate the invited speakers, plenary speakers, and all of you who presented and participated in the discussion for your nice contribution. So the certificates will be submitted to participants later. Am I right, Nejat?
Yeah.
So you will get it.
And I see on the Professor Abdul Jawad. Are you here? I see the name.
Yes.
Oh,
I am here.
Would you like to say anything?
Sorry. Actually, I was not following carefully because I still wake up.
All right. Okay. I see the name. That's why that. Okay. And I see I mean, in here, he's also a part of our conference participant. I would like to be his Cihan Bayındır Hocam. Would you like to say anything? I see are you?
Thank you very much for giving me the word, and I congratulate the organization, and I would like to thank the organizers for this great event in the shadow of the pandemic. So making such a accurate organization is not easy thing to do. So me and my students, so we contributed to, I guess, 8 basically presentations, and we aim to publish them in the proceeding format. So, well, I assume that the proceedings are going to be in the same format as the abstracts. And then I guess the page limit is 6 pages. So maybe a little clarification on the proceedings could be a good contribution. And well, generally, I would like to thank again, and then we would like to contribute to the conference in the near future again. And thank you very much for everything.
All right, thanks, Hocam. I think we can see on here proceeding in here as well. So we already published in 1918. So this time also we are going to do proceeding as well. I hope your question in here and your remark in here. And,
yes, sir. We have seen this, but the format is going to be exactly in the abstract format, we assume. So we follow.
We are going to be sharing with this all participants. We are going to be sent all necessary format as well.
Okay, I was in Balıkesir in 2018, so I follow it.
All right, you know that. So more or less same thing, so no problem.
Okay.
I hope so. Not much difference.
Thank you so much.
Okay, thank you. Mm-hmm.
Again, thank you for all.
All right, that's it. Thank you for joining and walk together last 3 days. I hope you will be enjoy and we get much benefit each other. And we see next time in Balıkesir. I hope so. We would like to be a hospitality, and also we can meet some other conference as well. Thank you very much for joining us.
Bye-bye.
Thank you. Bye-bye. So we are going to be switching a parallel session, please.